Okay, so we'll start with our first one here. This is, all we're doing here, right, is if we have dy on dx is equal to f of x, then the integral of f of x with regards to x will equal y. Now this is exactly what we learn in methods. We're just like, if this is dy on dx and you integrate it, you're going to get the original function y. That's what we mean here. So let's start with our first one. We're going to solve the differential equations. We have dy on dx equals x to the half. I'm going to straight away write it as with its power. Now what we're effectively doing, okay, is if we want to find the equation y, we're going to integrate both sides with respect to x. So you can think about it like that, okay? If I go to integral of dy and dx with regards to x is equal to the integral of x to the half with regards to x. Now here we have dx at the top and dx at the bottom, that will cancel. And so what's going on the left-hand side is we have just the integral of dy, but what we're integrating, we've got one lot of dy. Remember when we have an algebraic variable, there's no number out front and we assume it's 1, so we've got integral of 1 with regards to y. The left-hand side will integrate to y, and the right-hand side will integrate to x to the half plus 1 on top of half plus 1. Okay, so that gives us 3 on 2, x to the 3 on 2 on 3 on 2, 2 on 3, x to the 3 on 2. We'll simplify 2. Plus c. Now the plus c applies as soon as we perform the integral. Now, so what we've done there is exactly what we would do in methods, except we've got probably some more spec notation, integrating both sides with respect to x. We've found the general solution. The general solution to this differential equation, because of the plus c, that it satisfies all of the possible vertical translations of that function. Okay, on to b. We have dy on dx, take away 4 equals cos of x. So the first thing we're going to do is move the 4 over to the right-hand side. And then we will integrate both sides with respect to x. Doing the same thing to both sides. On the left-hand side, we're going to have y, and on the right-hand side, we're going to have the integral of cos is positive sign. The integral of 4 is 4x, and then plus c. There's the general form. All right, c. dp on dt is 1 on t plus 2. Okay, integrate both sides with regards to t. So over here, our variable that we're integrating to is p, and on the right-hand side we have 1 on ax plus b. This goes to 1 on a ln modulus of ax plus b, and then plus c, where 1 on a is the coefficient of the variable. Alright, so this is just ln of modulus t plus 2 plus c. Alright, so we're familiar with those rules. Last one, when we're finding an exact particular solution, again, seems similar to methods, but we'll use some spec notation. dy on dx equals 2x plus 4. We're going to integrate both sides with respect to x. So we'll have here y, over here we'll have x squared plus 4x plus c. And then to find the particular solution, we have y of 0 equals 3. That means when x is 0, y is 3. We'll plug that in. and C. Therefore, y equals x squared plus 4x plus 3. All right, any questions about those? It's a pretty straightforward exercise, this one.